Hello, this is the first of the videos about atoms, so I'm going to talk briefly just about the basic structure of the atoms. I'm going to get a label diagram and just talk about a few of the particles. So atoms are the tiny particles that make up all matter, and a word that's often used about atoms is that they are indivisible. Indivisible means that they can't be divided. We can't break an atom into any smaller parts except for in nuclear reactions, but we're not going to talk about that. Atoms, however, are composed of smaller bits. We just can't break it into these smaller bits. We're going to look at those small parts that make atoms up. So we know that within the atom, which is tiny, we've got a nucleus. The nucleus is in the middle, and it contains protons and neutrons. Overall, the nucleus is positive because the protons have a positive charge. So if I get labelling, protons and neutrons, and then in terms of charge, protons have a charge of +1. The neutrons don't have a charge. Their charge is just 0. These two particles also have mass. They have the same mass as each other. So the relative charge is +1 and 0, and the relative mass is just 1 and 1. It just means compared to each other, they've got the same mass. This isn't in kilograms or anything. That's just compared to each other. Okay, on the outside of the atom then we've got other particles, and these are far smaller and they're negative, and these are called electrons. This is what J.J. Thomson discovered. And compared to protons and neutrons, electrons are very, very, very small, and therefore their mass is absolutely tiny. It's negligible, which means pretty much 0, as good as 0. 0.0005. It means when we're thinking about the mass of atoms, we can ignore the electrons. It's the protons and neutrons that affect the mass of it. In terms of charge, their charge is -1. So these are the key facts to remember about protons, neutrons and electrons. The other thing we know is that the protons and neutrons are in the nucleus, and the electrons Niels Bohr discovered are in these electron shells, which is where they've got to stay. Okay, a word about size of these things then. Atoms are absolutely tiny. So the radius of an atom overall is about 10 to the power of -10 meters. And what that means is 0.1, 2, 3, 4, 5, 6, 7, 8, 9. And then that 1 is the 10th decimal place meter. So it's a 10 billionth of a meter. And that's absolutely tiny. It's a rough value. Different atoms are different sizes, but that's roughly what it is. It's very, 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 very small. However, compared to the atom overall, the nucleus of the atom is far tinier still. So the size of the nucleus is 10 to the power of -15 meters. If we look at the difference in size between the atom overall and the nucleus, we see that the atom overall is 10 to the power of 5 times bigger. That is, it's 100,000 times bigger, which means that this nucleus only takes up a tiny, tiny, tiny amount of the atom overall, and that's what Rutherford discovered in his gold foil experiment. So that means that atoms overall actually are almost entirely just empty space. And the nucleus just is a tiny, tiny dot in the middle. This isn't to scale. If this was to scale, then the nucleus, we wouldn't even be able to see it. It'd be very small, and the electron would be even smaller. Okay, finally, just a word about the different types of atoms, and we'll look at this in the next video. Different types of atoms are found in the periodic table, different elements. and it's the number of protons that defines what type of atom it is. That's the important one. That's how our periodic table defines the different types of atom. So I'm just going to write, if there are different numbers of protons, then that just means that these are different atoms. If there were to be a different number of neutrons, neutrons don't affect the charge of an atom, but they do affect the mass of the atom. So they'd have different masses, and the term that we use for that is isotopes. We'll look at that in a separate video. And finally, if there were different numbers of electrons, if we look at electrons, they do not affect the mass of the atom, but they do affect the charge of the atom. So different numbers of electrons in an atom would affect the charge of the atom, and that results in particles called ions. And again, we'll look at that in a separate video as well. So there you go, that's the diagram of a basic structure of the atom.